In this video, we'll be using the Kirchoff's second law to find three currents in an electrical unit consisting of two junctions with three resistors. Resistor 1, which equals 2 ohms, resistor 2, which equals 1 ohm, and resistor 3 is equal to 4 ohms. You also have two batteries within this electrical unit, and the batteries contain 6 volts going through there and also 8 volts. And with the current is traveling in a counterclockwise motion in this upper part of the electrical circuit. And in the lower part of the circuit, it will be traveling clockwise. This is counterclockwise, and this will be clockwise. Okay, so here's the setup. You have I sub 1 plus I sub 2, which will equal to I sub 1 plus I sub 3, excuse me, is equal to I sub 2. So junction 1 or junction 2, we will be applying the Kirchhoff's second law to the two paths, which will produce here R sub 1 times R sub 1 times I sub 1 plus R sub 2 times I sub 2, which will equal to 2 I sub 1 plus I sub 2, which will equal to 6. This is the 6 volts. And then you have resistors R sub 2 times I sub 2 plus R sub 3 times I sub 3, which will equal to I sub 2 plus 4 I sub 3, which will equal to the 8 volts. Now, as you see, this is set up like in a linear combination. And of course, we'll get into those linear combinations later in later videos. Okay, so we will clear this. Make sure you copy this information down. And so we will go and we'll clear this board so that we can continue on to solving this problem. Now, as you see, from the earlier setup, we will now actually set this up into a systems of equations. So this now will be I sub 1 minus I sub 2 plus I sub 3, which will equal to 0. Then we have 2 I sub 1 plus I sub 2, which will equal to 6. Then we have I sub 2 plus 4 I sub 3, which will equal to 8. Okay, let me remove that dot or that point, which appears to be a decimal point there. We don't want that because that's just 4 times I sub 3, which is equal to 8 there. Okay. So we have 3 equations with 3 unknowns. Okay. The currents are acting as I sub 1, I sub 2, I sub 3 are acting as if they're, values, or should I say, variable. Say, for example, variables like X, Y, and Z. And in this case, or acting as X of 1, X of 2, X of 3. Of course, different systems of equations will be set up in different ways with different variables. So in this case, the different currents are acting as the 3 unknowns. And you have 3 equations with 3 unknowns. So we'll set this up as a augmented matrix, a 3 by 4 augmented matrix, and then we will solve using the Gauss Jordan method, which will we simplify the system, or should I say the 3 by 4 matrix all the way down to reduced row echelon form, and then we'll continue to solve the equations and get our solution. So in this case, we'll write this as a 3 by 4 matrix. So 1, -1, 1, 0. This will be 2, 1, and 0. This will be 6, and this is 0, 1, and 4, which is equal to 8. So as you see, we talked in previous videos that we want to get a 1 here, which is already there, but we want to go into a pattern, and the goal is in this case for a 3 by 3. This is a 3 by 3 coefficient matrix here. This part of it. Overall, it's a 3 by 4 augmented matrix, but here when we talk about the coefficient matrix alone, we want to get the identity of this. So we want a 1, 0, 0, 0, 1, 0, and a 0, 0, 1 at these positions. Okay, so this for our coefficient matrix, we want the identities to be the identity matrix of a 3 by 3 just for here, and then that will get us our solutions in the process over here. Okay, so this is how we will solve a 3 by 4 augmented matrix using the Gauss Jordan method. So we already have a 1 in this position, so we want to get a 0 in this position. So what do? We will take -2 to row 1, add it to row 2 to get the new row 2. And how we do this will be 2 times 1, -1, and 1, and 0. And so this will be -2, this will be +2, -2, okay? And so this will be 2, 1, 0, and 6. And so we will say 0, 3, -2, and +6. That is our new row 2. So we'll write this again, including our new row 2, and the first row and the third row will stay the same for now. So this will be 0, 3, -2, 6. This will be 0, 1, 4, and 8. So look what we have here. So basically, we have our 0 here, and actually 0 here in this position. So our next position where we'll try to, in our attempt to get this to reduce row echelon form, is we could go over here to this position to get a 0 here. But I think what I want to do, and I showed you kind of, different patterns that you can go and just stick with that pattern, is that we want to get here I want to get a row leading one here in this position, the pivot point here. So at this position where this 3 is, we want to get a 1 there. So I'm going to divide 3, or divide by row 2 by 3 to get the new row 2. So we will say 0 over 3, 3 over 3, and we'll say negative 2 over 3, which will equal to 2. Does everybody see that? Okay. Now let's move this. Let's go to the next screen. So when we actually write this, this now becomes 1, negative 1, 1. This will be 0. And this will be 0, 1, negative 2 over 3, 2. This will be 0, 1, and 4, and 8. So we have the new row 2, and row 1 and row 3 will stay the same. So now what do we do next? We want to get a 0 here in this position. So we're going to take negative 1, we want to take negative 1, negative 1 to row 2, add it to row 3, to get the new row 3. So negative 1, we have 0, 1, negative 2 over 3, we have 0, negative 1, positive 2 over 3, and this is negative 2. Okay. And this is going to be added to row 3. So this will be 0, 0, and this will be, well, 2/3 plus 4, that's going to give you 14 over 3. And then this is negative 2 plus 8 will be positive 6. So here's our new row 3, and we have the first and second row will stay the same. So this will be 0, 1, negative 2 over 3. This will be 2. And this will be 0, 0, 14 over 3, and 6. Okay. So Next, what do we do? What do we want to have? We want to get a we want to get a 1 here. So we can divide 14 over 3 to row 3, or divide by 14 over 3. So we could take row 3 and divide it by 14 over 3. Or we could just simply take the reciprocal of 14 over 3 and make this 3 over 14 times row 3 to get the new row 3. So when we do this, this will be 0, 0, 14 over 3, 6. So this will become 0, 0, 1, and then 3 over 14 times 6 is going to give you 9 over 7. Okay, 9 over 7. So that's our new row 3. Make sure that everybody has this copied down. You can pause the video, copy down the notes. We will then proceed to the next screen. So writing this, we have 1, negative 1, 1, 0. We have 0, 1, negative 2 over 3, 2. We have 0, 0, 1, and then this is 9 over 7. Okay, so now we want to get a 0 in this position here. We want to get a 0 in this position. So we take positive, or should we say positive 2 over 3. I'll bring this over a little bit. Sometimes when I go too far, when I do the final production of this video, my writing usually get off the page, so I have to end up doing the video over again, doing some editing. So I want to make sure that everything is within the borders so that everybody can see. All right, 2 over 3 times, or should I, let me write the algorithm out. So that's going to be we'll take positive 2 over 3 times row 3, add it to row 2 to get the new row 2. So now when we show this, this is going to be 0, 0, 1, and this is 9 over 7. Okay, so distributing this is what we get. This will be 18 over 21 added to row 2. Okay. And this is going to be 0, 1, 0, and then this is going to be 20 over 7. So rewriting this, we have our new row 2. row 1 and row 3 will stay the same for now. Zero, 1, 0. This will be 20 over 7, and so this will be 0, 0, 1, 9 over 7. Okay, so next, what we're going to do is we want a 0. We want a 0 in this position here. We want a 0 here. So we're going to take -1 to row 3, add it to row 1 to get the new row 1. So by doing this, we'll say -1. This will be 0, 0, 1, 9 over 7. And that's going to be 0, 0, -1, -9 over 7, which is going to be 1, -1, 1, and 0. This is going to end up being 1, -1, 0, and this is going to be -9 over 7. So that's our new row 1. Row 2 and row 3 will stay the same. So what do we have? We have 1, -1, 0, -9 over 7, and 0, 1, 0, 20 over 7. And then we have 0, 0, 1, 9 over 7. Okay, our last algorithm basically, and our last position will be getting a 0 here in this position. So we're going to take and add row 2 to row 1 to get the new row 1. Okay, row 2, and this is row 1. There we go. Okay, so this will be 1, 0, 0. So 20 over 7 minus 9 over 7, that's going to give us what? It's going to give us 11 over 7. There we go. Solutions. Our current, first current is going to be 11 over 7 amperes, but we're going to actually round this to change this, convert this to a decimal, and I'm going to round this to the nearest tenths. So this is going to equal to approximately 1.6 amps. So 2, that's going to be 20 over 7, which is approximately 2.9 amps. And 9 to 3, it's going to be 9 over 7 amps, which converts to 1.3 amps. And actually, you can take these fractions and substitute them back into the original equations just to check your solutions and to see if I'm correct. This is correct. I checked earlier. And so this concludes the Kirchoff's second law for solving the system, the circuit.